Picture this: a silent region of space where nothing should exist. No stars, no dust, no galaxies. Yet James Webb just detected something there. Something so dense, so ancient, and so violently out of place that scientists worldwide are calling it the most alarming discovery of the decade. A dark, compact object bending light, warping space, and behaving unlike anything formed by stars. And if the early data is right, this thing shouldn't exist at all. When the first images came in, the team at the Space Telescope Science Institute didn't think much of it. Just another deep field observation, one of the countless snapshots James Webb takes as it peers further into the cosmic dark. But something about this particular data set felt wrong. There, suspended in a region where the universe should have been quiet and uneventful, was a gravitational distortion so intense that it bent the faint light of distant galaxies behind it. That alone was strange, but not impossible. Massive objects like black holes can do that. In fact, gravitational lensing is one of the clearest signs that something heavy is lurking in the void. But this wasn't a typical lens. This was sharper, tighter, more compact, almost surgical in how it twisted space-time. At first, the team suspected an error. Webb's instruments are incredibly sensitive, maybe too sensitive. Could it have been a calibration issue, a software glitch, a misread pixel? But after rerunning the data, reprocessing the images, and cross-checking with independent software, the distortion persisted. It wasn't a mistake. Something out there was warping reality itself. The troubling part: whatever it was didn't appear to be located inside a galaxy. It wasn't orbiting one either. It sat alone in the cosmic wilderness, an object with no home, no parent star, no surrounding structure. And that's when alarm bells started ringing, because objects this compact shouldn't form in empty space. Stellar black holes require stars. Neutron stars require supernovae. Supermassive black holes require galaxies. But this was floating freely, as if it had simply appeared. To make things even stranger, Webb's spectrometers detected no typical signature of matter falling into it. No hot accretion disk, no X-ray emissions, no visible jets. Whatever this object was, it was swallowing light and matter so cleanly and silently that it almost looked engineered. Meanwhile, gravitational readings hinted at something even more unsettling: a mass far smaller than any known black hole, yet compact enough to mimic their behavior. Some researchers began whispering an old controversial idea: primordial black holes, hypothetical relics of the early universe, objects formed not from stars, but from the unimaginable pressure fractions of a second after the Big Bang. Scientists believed they evaporated long ago. If they ever existed at all, they were theoretical ghosts, mathematical curiosities. But this new Webb target behaved exactly like one. As news spread through the astrophysics community, theories erupted. Some argued it could be an ultra-dense star cluster too small to resolve. Others suggested a collapsed dark matter clump, something never seen before. A few even wondered if it was a wandering singularity ejected from a galaxy billions of years ago. But there was one question no one wanted to say out loud: if this truly is a primordial black hole, what else is out there? To understand why Webb's discovery is sending shockwaves across astronomy, we need to travel back, way back, to the very beginning of time. Not millions of years, not billions, but to the first 1/1,000,000th of a second after the Big Bang. In that moment, the universe was unrecognizable. There were no stars, no galaxies, no atoms, only an unimaginably hot, dense ocean of pure energy and subatomic chaos, fluctuating, boiling, collapsing, and expanding in violent bursts. Imagine a sea of particles so dense that space itself had no meaning. Pressures so extreme that entire mountains could be crushed into the size of an atom. Conditions so intense that for a brief heartbeat in cosmic time, the laws of physics wavered. This era was called the Primordial Epoch, and for decades scientists have wondered, could black holes form here? Not from dying stars, but directly from this raw, newborn universe. This is the idea behind primordial black holes, tiny, ancient singularities formed from density fluctuations in the first moments after creation itself. If a patch of the early universe became just slightly denser than its surroundings, gravity could have collapsed it instantly into a black hole. No stars needed, no galaxies required, just pure, overwhelming pressure. For many years, this remained theoretical, a beautiful equation on paper, but with no proof. These primordial black holes could have ranged in size from microscopic to thousands of times the mass of the Sun. Some could have evaporated through Hawking radiation, others might have persisted, and a few, only a few, might still be drifting silently across the cosmos. But until now, we had never found anything that matched their predicted behavior. Webb's new target, however, was different. It was too small, too compact, too isolated. It had no visible source of formation. It behaved exactly like a relic of the early universe. Astronomers began revisiting old studies. Back in 2024, a team published a controversial paper suggesting that Hawking radiation, the process that causes tiny black holes to slowly evaporate, might drastically slow down as the black hole shrinks. In some models, it nearly stops altogether. Instead of disappearing, the black hole stabilizes into a long-lived, ultra-dense object, a black hole that refuses to die. If this was true, the early universe could still be littered with these frozen remnants. Most would be tiny, some no bigger than a proton, yet holding the mass of a mountain. Others could be larger, the size of a pebble, a fist, or a house, depending on their origins. And then came the most shocking revelation. A sufficient swarm of these tiny black holes could mimic the gravitational effects of dark matter. Dark matter, one of the greatest mysteries in cosmology, an invisible force that holds galaxies together, something we have never seen, never touched, never identified. What if it wasn't a particle? What if it wasn't exotic physics? What if the universe was filled with trillions of ancient microscopic black holes left over from the first second after the Big Bang? It's a theory many dismissed as fringe, too strange, too outlandish. But Webb's inexplicable discovery suddenly breathed new life into it, because the object it detected was exactly where you would expect dark matter and primordial remnants to hide, in the empty outskirts of intergalactic space, far from stars, far from galaxies, invisible except for the gravity it cast like a silent shadow. And that leads to a chilling possibility. If Webb truly found a primordial black hole, it might not be alone. There could be millions, billions, an entire population drifting through the cosmic dark, some harmless, others massive enough to disrupt star systems, a few potentially passing close to our own galaxy, perhaps even through it. And if that's true, then this discovery is not just alarming. It's a warning. As speculation intensified, NASA scheduled a deeper set of observations. If this object truly was primordial, its gravitational footprint should reveal subtle clues, distortions in the background glow of the universe, slight bends in the fabric of space-time, patterns too precise to be random. So Webb stared again. This time, astronomers used a technique called microlensing, watching how the object's extreme gravity magnified the light of more distant galaxies as they drifted behind it. And what the data showed stunned the team. The gravitational lensing was too clean, Black holes formed from stars are messy. They're surrounded by dust, debris, distorted gas, tangled magnetic fields. Their gravitational lensing usually shows ripples, imperfections, turbulence, signs of a violent birth from supernova explosions. But this object produced a lens so perfectly smooth, so mathematically precise, that it almost looked artificial. There were no fragments around it, no leftover elements, no chemical fingerprints of a collapsed star. Just a compact object bending light in the purest way possible. Something ancient, something untouched. Then came the second anomaly. Webb detected a faint, almost imperceptible temperature signature. Not heat from matter being swallowed, but a subtle glow consistent with theoretical predictions of ultra-slow Hawking radiation. Not enough to evaporate it, not enough to destroy it. Just enough to suggest it was shrinking, but at a rate so slow it might continue existing for trillions of years. This was the first time any telescope had ever captured a signature that lined up so closely with what primordial black holes were predicted to emit. Finally, scientists examined the object's surroundings. In normal scenarios, a wandering black hole would distort the motion of nearby stars or gas clouds. But here, there was nothing to disturb, only empty space. It moved silently, invisibly, with no detectable origin. It behaved like something that had always been there, not formed, not born, just existing. An ancient survivor from the universe's violent birth. And if that wasn't alarming enough, Webb's instruments detected minute fluctuations around the object, tiny gravitational tremors. Almost like echoes. They were too small to be caused by the main object itself, which meant something terrifying. There might be more than one. A cluster, a swarm, a trail of tiny black holes drifting together across intergalactic space, completely invisible, unless you looked with the right eyes. And suddenly, scientists realized this might not be an isolated anomaly. It might be the first glimpse into a hidden population. The more scientists analyzed the data, the more an unsettling picture began to form. If Webb had indeed found a primordial black hole, and if the faint gravitational tremors around it implied multiple objects drifting together, then we were looking not at a cosmic rarity, but at the first confirmed member of an entire hidden ecosystem. A population of ancient black holes that had gone undetected for the entire lifetime of civilization, not because they were small, but because they were perfectly dark, perfectly silent, and perfectly camouflaged within the cosmic void. And that realization opened the door to a terrifying question. If these objects are real, where are the rest? Because the universe is enormous. 13.8 billion years of expansion, trillions of galaxies, uncountable light years of empty space. If one primordial black hole ended up in Webb's narrow field of view purely by chance, then the statistical implication was staggering. There could be millions of them per galaxy, maybe billions across the universe. Not theoretical, not evaporated, not extinct, alive. Moving, waiting, some drifting harmlessly through intergalactic space, others perhaps orbiting galaxies, and a few, just a few, passing directly through them. This led researchers to revisit an old mystery, the strange, unexplained movements of certain stars on the outskirts of the Milky Way. For years, astronomers detected minute deviations, tiny, sudden changes in velocity that didn't match gravitational models. They were labeled anomalies, observational noise, or statistical outliers. But now, these inconsistencies took on a new meaning. What if those stars weren't behaving strangely? What if they were reacting to something passing nearby? Something small, something heavy, something invisible, a primordial black hole. The implications stretched far beyond astronomy. If these objects were abundant, they could reshape our understanding of dark matter, the mysterious unseen mass that makes up 85% of the universe's gravity. Scientists had long suspected dark matter was made of unknown particles, but a radical subset of physicists argued a different idea. Dark matter might not be particles at all. It might be black holes, not the massive kind at galactic centers, not the stellar ones formed from dying stars, but tiny, stable, ancient black holes formed in the first second after the Big Bang. Webb's discovery suddenly propelled this fringe theory into the spotlight, because the object it detected was exactly where dark matter should hide, in the outskirts between galaxies, exerting gravitational influence without emitting light. If primordial black holes are the true identity of dark matter, then they must number in the billions. They would form vast halos around galaxies, influencing the motion of stars, shaping cosmic structure, and silently guiding the evolution of the universe, all without ever revealing themselves directly. But with that possibility came a chilling realization. If tiny black holes are everywhere, then the space between galaxies is not empty. It is a minefield. Imagine a spacecraft traveling through deep space, far from stars or planets. In the vast, dark silence, the greatest danger has always been assumed to be radiation, mechanical failure, or the crushing loneliness of the void. But what if the real threat is something completely invisible? A microscopic singularity the size of a proton flying at thousands of kilometers per second with the mass of a mountain. A single collision could shred a ship instantly, tearing metal into dust, just as it destroyed the fictional Wanderlust probe in the story that opened the competitor's video. That scenario, once pure speculation, now seemed uncomfortably plausible. There was another problem too. If primordial black holes are common, then there's a non-zero chance, however small, that one could pass through our solar system. It wouldn't behave like an asteroid. It wouldn't heat up, glow, or leave a trail. It would glide silently through space, its gravity barely detectable, until it came dangerously close to a planet. Even a tiny one, no larger than an atom, could distort orbits, destabilize moons, or swallow small amounts of matter as it passed. Not enough to destroy Earth, but enough to cause measurable, perhaps catastrophic effects. And if one were larger, say, the mass of a mountain or a small moon, the consequences could be far more severe. Scientists aren't sounding alarms. They aren't predicting disaster, but they are now forced to consider possibilities they once dismissed, because Webb didn't just detect something unusual. It detected something that may rewrite the structure of the universe, something ancient enough to predate galaxies, something dense enough to warp space itself, something that may exist in numbers far beyond anything we can imagine. And if the early analysis is right, this discovery could be the key to solving one of the biggest mysteries in cosmology, or the beginning of a completely new one. As the data continued to circulate through research institutes around the world, one unsettling truth became unavoidable. Whatever Webb had detected was not an isolated cosmic oddity. It was a clue. One that pointed toward a universe far stranger, more dangerous, and more unpredictable than we ever imagined. For decades, we mapped the cosmos under a comforting assumption that most of what exists follows rules we understand. Stars form, shine, and die. Galaxies collide. Black holes grow. Nothing appears out of nowhere. Nothing hides without reason. But this discovery challenged all of that. Here was an object with no origin, no environment, no signature of birth or death. Something too small to be a stellar black hole, too dense to be anything else, and too precise in its gravitational footprint to be random. A relic not of stars, but of creation itself. And for the first time, humanity had to confront the possibility that the universe is populated not just by wonders, but by ancient dangers. Because if primordial black holes truly exist, then they are not mere cosmic leftovers. They are fossils of the universe's first heartbeat, remnants of pressures so great, temperatures so impossible, and densities so overwhelming that they defy intuition. They are the oldest objects in existence, the most enduring, the most secretive, and they are still here, somewhere out there, drifting in silence, somewhere even closer than we think. Silent observers of 13.8 billion years of cosmic history. Maybe they shaped galaxies. Maybe they shaped dark matter. Maybe they shaped everything. Yet the most alarming question isn't how many of these objects exist, but how close the nearest one might be. Could one be drifting through the outer halo of the Milky Way right now? Could one be passing between the orbits of distant stars? Could one, by some improbable chance, wander through our solar system in the next million years? Scientists emphasize that the chances of disaster are extremely small, but for the first time, they can't say the chance is zero. They can't dismiss the idea as fantasy. The universe has just handed us a reminder that there are still things out there, ancient, silent, invisible, that we barely understand. And that's why this discovery is so alarming. Not because it threatens us today, not because it guarantees catastrophe, but because it reveals a cosmic truth we've avoided for a long time. The universe is not empty. The dark is not harmless. And the things we cannot see may be shaping reality in ways we've never considered. As we continue exploring the cosmos, launching telescopes, probes, future interstellar missions, we may encounter more of these relics. Some may answer our deepest questions. Others may raise new ones we aren't prepared for. But one thing is now clear. James Webb has not just expanded our vision, it has pierced the darkness. And for the first time, the darkness has stared back. So I'll leave you with this. If primordial black holes are real, and Webb has just seen one, what else is hiding in the void? And are we ready to find out? If this journey through the cosmic shadows fascinated you, make sure to like this video so it reaches more curious minds like yours. Subscribe to stay updated as we uncover more strange and breathtaking mysteries hidden across the universe. And tell me in the comments, do you think primordial black holes could be the true identity of dark matter? Or is this discovery pointing towards something even stranger? I'm reading every single one.